Hello students, today we are going to be looking at how to factorise quadratic expressions. I hope that by the end of this presentation that you will be able to factorise quadratic expressions like this one in the top right quite easily. So without further ado, let's get started, hey? Before we begin the hard, scary stuff, we will start off with some more simple examples that you may or may not be familiar with. Example 1 gets us to factorise the expression 6x squared minus 24. Now the first step is to group together like terms. As both 6 and 24 can both be divided by 6 to get 1 and 3, we can divide 6x squared minus 24 by 6 and place the 6 out the front of some brackets. This leaves us with 6 bracket x squared minus 4 bracket. Moving on to example 2, which is a similar problem and gets us to look at the expression r squared plus 4r. If we see which terms are common between r squared and 4r, we see that both contain an r. We will then place the r outside of a bracket which contains r squared plus 4. And a bit of a hint, always when looking at these expressions, find the highest common factor and write it outside the bracket like we just done in these two examples. Now on to the climax of this presentation, but don't be intimidated, they won't be too horrible shortly. You will see that they all take the form of x squared plus bx plus c, and to factorise these, you have to find two integers that multiply to give the c and add to give b. Example 3 has us factorise the expression x squared minus 2x minus 8. So which two integers multiply to give 8, which is c, and add to give negative 2, which is b? You should have found out by now that it is 2 and negative 4 through either trial and error or some form of problem solving. Okay, remember this is expansion in reverse. So you need to end up with an expression that expands to give x squared minus 2x minus 8, which you find is bracket x plus 2 bracket bracket x minus 4 bracket. This might still seem a little bit difficult, but with two more examples, these questions hopefully will be a lot less scary. Example 4 gets us to factorise a similar problem to example 3, which is y squared minus 8y plus 15. First step again is to find which two integers add to give b, which is negative 8, and multiply to give c, which is 15 in this expression. Again, through some trial and error, the two integers turn out to be negative 5 and negative 3. Therefore, y squared minus 8y plus 15 equals bracket y minus 5 bracket bracket y minus 3 bracket. Now for a bit of a throwback to the first two examples, the first step here is actually the very first step, which is to find the highest common factor, and it is, of course, 3. You will get 3 bracket x squared plus 2x plus 1 bracket. For the second step, we would not worry about the 3, so just imagine that it doesn't exist for a few seconds. And if it's on a screen in front of you, just put your hand over the 3 and block it out for a minute. Now, what two integers multiply to give 1 and also add to give 2? This is easy. Well, it is just 1 and 1. Therefore, the expression 3x squared plus 6x plus 3, now you can bring the 3 back in and put it out the front. 3 bracket x plus 1 bracket bracket x plus 1 bracket. All better? Alright guys, this is the end of this presentation for today. I hope I have made it a lot easier for you to factorise quadratic expressions, both simple ones and even the more nasty ones. Alright, have a good day guys. I'll see you next time.